Hi, I'm Arab from RT Robotics, and today I'll be showing you how to use the operator library in Scratch. So the operator library is mainly just used for math. So as you can see, we have a lot of operators, and this one has got a lot, which I'm going to explain today. So first, we're going to make a little bit of code for this. So when green flag is clicked, and say hello. So the first thing is adding. So these are just the basic operations like addition, subtraction, multiplication, division. So addition, this is subtraction, multiplication. This is an asterisk. Normally in math, we either use an X or a dot in the middle. But in coding, we use asterisks to symbolize multiply. And just wanted to get that out of the way as some of you might be confused about why it's an asterisk. We also have divide. And here, although many of you might use this as a divisional symbol, this is actually used to represent a fraction. So a fraction is like division, it's the same as division, except it's easier to represent recurring and really long numbers. So the definition of a rational number is that it can be shown as a division. And the reason that the division symbol is like this and is to represent fraction. So top dot is to represent the numerator and the bottom dot is used to represent the denominator. So I hope you understood that. Next is the pick random. This just picks a absolutely random integer between 1 here it's 1 and 10, but you can change the bounds of this. So here it's always going to pick a random integer between 1 and 10. The reason I'm saying integer and not number is because numbers also include decimal numbers like 1.2 and recurring numbers like 1.3333333333 and so on and so forth. Then here, this is a condition. We know it's a condition because it's in a hexagon block. So here, the condition is the number is greater than 50. Here, it's the number is less than 50. And here is the number is equal to 50. So these are all used to just compare numbers, compare like values. These are also conditions. These are conditions used in Boolean algebra. This is something that I myself haven't covered, but basically what it is that it takes like say if you have true and true, the value here is true. True and false. So basically it just looks if they're the same or looks if it's either or one of the conditions and then not just checks if it is not the condition. These are very useful when dealing with conditions. So join just joins two values. So here, as you can see, if you join apple and you join banana, you get apple banana. This one tells you the index. Doesn't this one tells you what letter is in the index of the number here. So an index is just a number used to describe each character in a string. So the string here being apple. So letter 1 is index 0. So letter 1 of apple, so the first letter of apple is A. Here, the length of apple just is saying how many characters does the word apple take up. So as Scratch is saying, 5. This is a condition, as I said previously, in a hexagonal block. So if apple contains A, then it does something. So this just checks if apple or a string contains a certain character, here A. Next we have mod. So what mod does is it calculates the remainder when you divide the first number by the second number. So 10 mod 3, so that's 10 divided by 3, should be 1 because you have a remainder of 1. And so as you can see, that's what Scratch has also said. Round just rounds off decimal numbers. So say if I did 4.5, it should say, yeah, 5. Now, this is going to be a long one because the drop down section has a lot to cover. So, first is absolute. The absolute value of a number is just the positive value of that number. So, if you said had 5.6, then the absolute value, sorry about that, I have put two decimal places instead of one. So, 5.6, the absolute value, is going to be 5.6. But if you put negative 5.6, what do you think it would be? That's right. It would be 5.6. I always said negative, but it's not. Just regular 5.6. Next, we have floor. This rounds the number down. So here, so if you round negative 5.6 down, you're going to get negative 6. And ceiling rounds it up. So if you put negative 5.6 and you round it up, you get negative 5. Square root just calculates the square root of this number. Now, what do you think the square root of negative 5.6 would be? The answer is we have no idea. In math, there is this constant called I, which stands for an imaginary number. This number is imaginary because we cannot calculate the square root of a negative number. Sure, we can calculate the cube root, but we cannot calculate the square root. So it's going to just say NaN because there's no square root of a negative number. But if we use 5.6, then you get the answer. A useful way just to limit this is to use the absolute function. So even if you put negative 5.6, the absolute value of negative 5.6 is 5.6, and we can calculate the square root of that. After that, we have the basic trigonometric functions, sine, cos, and tan. These might be complicated if you're young, but these are just tools used to calculate different qualities of a triangle, like the angles and the side lengths. A sine, A cos, A tan, arc sine, arc cosine, arc tan. These are all used to find. These are all the inverses of each of the previously stated trigonometric functions. So sine is arc sine's opposite. Arc cosine is the opposite of cosine. Arc tan is the opposite of tan. Next we have ln, also known as natural log. So what the natural log does is that it calculates what the exponent is, meaning the number that you'd raise a number to the power of when you raise it to the power of e. So what I mean by that is the natural log of 10 is the number that you'd raise e to the power of to get 10. So if we put 10, we get 2.3. And keep that number in your head as we will be using it later on in the video. And next is log. This does the same thing for natural log, except it does it with 10 rather than e. So the natural log, so the log of 10 would be 1, because if you raise 10 to the power 1, you get 10. After that, we have e to the power of. So this is the opposite of natural log. If you actually did what I said, well, good job. You have better short-term memory than most kids out there. If you didn't, go see a doctor, please. Anyways, if we raise e to the power of something, and our previous number was 2.3, if we use that, we should get 9.97, which is 10. And the same thing can be said for 10 to the power of. And thank you for watching, and I hope I see you next time.